Hey, welcome to NASA Edge.
An inside and outside look at all things NASA.
Hey, we got a great show lined up today. We're going to be focusing on a couple missions from NASA Dryden Flight Research Center in California, Edwards Air Force Base.
That's right.
But before we actually get to those topics, we're going to have a little game we're going to play this morning.
Yes, but I have an important announcement before we get started.
Okay.
If you know the Mitchell Report, lately came out. I just wanted to let the record show that I have never taken steroids of any kind. I'm clean. As a matter of fact, the only juice I've had is like orange juice and occasional, when I'm reckless, pomegranate juice. So I'm clean. I don't know about the rest of you guys.
But Blair, one thing that's happened, you've gotten smarter.
Yeah,
Yes.
Yeah,
that's right. You're with immediate not training.
Exactly.
That's correct.
And
you're
so,
becoming more of an insider.
I just, I know that I'm a professional and I am athletic, but I have never taken any of this.
Well, I tell you what, enough about you and your ego for right now, but let's get to the game. That's kind of the focus here in this segment.
Well, I had to start before the game because I'm going to beat everybody, and I didn't want you to attribute it to steroids.
All right, what we're gonna do is we're gonna play a new game. It's called the 50th anniversary game. As you know, it's the 50th anniversary for NASA. And so we're gonna play a little game between Franklin, you and I, where we have to come up with the top 5 NASA missions of the past 50 years. The winner is, we're gonna see when we name our top 5, the ones that we have left standing on our sheet is
that are unique.
They're unique, because let's say, for example, I choose
the moon landing.
The moon landing.
Let's say that's too obvious.
That is very obvious.
Yeah, that's obvious.
Well, you just scratch that out.
That's a gimme.
That's a gimme. That's a mulligan.
Okay, Franklin, we're gonna start with you. We want you to give us your number 5 pick.
Deep Impact.
Deep. Why did you choose Deep Impact?
Deep Impact. You know what? That is the equivalent of like throwing a baseball in the air in Japan and shooting it out of the sky from the United States. It's just out of control. The whole just to think of an asteroid coming through space and then hitting it with a object and then taking these pictures.
Yes, it's very cool.
Impact.
Okay.
In other words, it's like how Blair got a job. It's just like
absolutely.
You know what?
There you go.
It's just an awesome.
Okay.
Deep Impact. What's your number 5?
I didn't have Deep Impact.
I didn't have it either.
So he's
one
already
for you.
Already one for him.
That's good.
I went with the pen that can write upside down. The astronaut pen. So that you can, when you're lying, or when you're in, remember the astronaut pen where you can write upside down and gravity doesn't affect it.
Did you read the instructions for this game?
I thought that was a significant accomplishment.
All right, well, NASA pen.
And I gathered neither one of you thought of that one.
It's not a mission. It's an accomplishment. We said mission, but that's
Is Deep Impact
was a mission? Yeah.
Okay.
Well,
I'm a little.
Did you have NASA pen on yours?
No.
Okay. Well, that's one for him. That's debatable. That's debatable.
All right.
Okay. Mine was. I'm going for significance. Something that really changed the way we explore. And my number 5 was the International Space Station.
Oh, ISS.
Yes, ISS.
Okay. Yeah, I had ISS.
You had ISS. Did you have ISS?
Did not have ISS.
Okay. Well, that doesn't count for me because you had it. So
my 4th one was the scramjet.
The scramjet engine.
Yeah, the scramjet engine. Because I think that's pretty significant. I mean, am I wrong?
What'd you have for number 4?
My number 4 was the Mars rover.
Okay,
I did not have Mars rover.
I had the rover on mine.
I had Hubble for number 4.
Okay.
I had Hubble.
I had Hubble too.
Because that's hands down Hubble.
Yes, I had Hubble.
All right, so that number 3. I'll start here. Voyager 1 and 2. You had Voyager 2?
I had Voyager.
Man,
I had Voyager.
All right, well, we know Voyager 1 and 2 is our first 2 spacecraft. They're going to be, right now they're on the cusp of leaving.
Yeah, and also they're
Milky
responsible for key dramatic changes in the Star Trek movie.
Well, what's your next one that you have? Number 2?
Shuttle.
I had Shuttle too.
Huh?
Yeah, because, well, Shuttle is just, you can't. Why not? You can't. You have to have shuttle on your top 5 list.
But see,
it's kind of crazy not to have it.
Yeah, it's just been the workhorse of NASA.
Since 81.
According to the rules, you wanted unique, so I didn't want to put the shuttle. I went with the pen.
But they're important missions.
They are important.
We're going with missions.
Yeah, missions, not uniqueness of an accomplishment.
All right, just a little.
It's not innovation fabrication.
That's right.
Although that was a good game.
All right. Well, and my number 1 was the Apollo landing.
But we said that didn't count at the beginning. We threw that out. That's the mulligan.
That's
the mulligan.
And
why are you throwing it out though?
well, it's very significant, but it was a gimme.
Oh, I just assumed we all had it down as a gimme on our sheet.
It is a gimme.
Now, but that's a technicality. Did you have it on your list?
I had it on my list.
Did you have it on your 5?
I didn't put it on my 5.
I didn't put it on my 5. You by technicality, you get it. But we were going to throw that out, but you put it on your list.
Yeah, because that's when you said gimme, I thought you said, well, yeah, everyone has it on our list because I was going to scratch it since we all had it. But since I got it, that's 1 point.
It's a tie.
We all tied.
It's just like kissing our sister. We need a tiebreaker. What do we do for a tiebreaker? NASA pin.
Tell you what, let's go to the music, background music, and then we'll get some time.
All right.
And then we'll come back.
Okay. All right. But I still don't okay. All right. Yes. All right. Background music. You're watching NASA Edge Influx.
And inside and outside look at all things NASA. We'll be back in 10 seconds.
Yeah. Okay. But I could write with the NASA pen.
Hey, we're back. Sorry for the quick break, but we wanted to have a little
tiebreaker.
Tiebreaker. Okay. So what's your tiebreaker?
Well, Skylab.
I got Skylab on mine.
So, Franklin, what do you got? If you don't have Skylab, you win.
You win. So
I don't have Skylab.
So what'd you have?
Pioneer.
Pioneer was, that's right. Pioneer was a good. In fact, wasn't Pioneer one that you covered in an old news segment?
Probably.
Yes, it was an anniversary. Yeah.
Mm-hmm. Well, he's drawing on past news experience. That's okay, all right. Well, I'm upset. I think really I should have won with the pen. But
let's take a break.
Yes.
And we'll kind of settle down a little bit.
Settle down a little bit.
Get our bearings
and do
straight.
The news.
And
we'll come back. And Franklin, are you ready for the news today?
And man, I got something special for you today.
Oh, cool. Looking forward to it.
Love surprises.
You're watching NASA Edge.
An inside and outside look at all things NASA. I looked at every camera. It's like,
I was about to say something. You screwed up.
How did I screw that up?
I was about to say, we were supposed to continue talking after.
Oh, okay, okay.
All right, let's do that again.
Cut!
Hey, welcome back to NASA Edge.
An inside and outside look at all things NASA. I'm sorry. I just want to say I'm about the competition. Next time, I'll be more prepared. But there was a discrepancy. I'm sorry. I'll have better events, and maybe we'll have a better competition next time.
Tell you what, let's get to the news segment with
Good
Franklin.
idea.
Franklin, what's going on?
Hey, guys, in the news today, we're going to do something new. I actually got together with our social networking friends over at Facebook and MySpace.
Awesome.
And actually have a young lady from Texas by the name of Carrie who's going to help us do the news today.
Oh, our Aggie friend.
Yes, on our entourage on Facebook.
That's right.
Perfect.
Yes, so we're going to get Carrie on the phone. Actually, Ron, is Carrie on the phone? Yeah.
Hey,
Carrie, how you doing?
Hey, thanks for coming out in support of NASA Edge and doing the news.
No problem.
After you deliver the news, we'll come by and give us
some
you
criticism.
Just constructive.
Constructive. Of course.
Yeah.
Of course, by all means. Okay.
So you ready to go?
Right, I'm ready.
All right, what's happening in the news of NASA, Carrie?
Yes, Carrie, tell us.
In early December, the Phoenix Lander team gathered at the Phoenix Operations Center at the University of Arizona in Tucson to perform an operational readiness test. They used a mock-up of the Phoenix Lander in a test bed with similar conditions to Mars, and they simulated the landing and a few days of operations on the Martian surface. The Phoenix Lander is currently scheduled to land on Mars on May 25th, 2008. And I have the privilege of working on this mission, too.
That's editorial. Yeah, I'm sorry. I got to break in here. All right, Carrie, that is interesting that you worked on that project, but as a news item, you want to remain more objective.
Okay.
Carrie, what's pretty cool is what did you do on the project? That's kind of cool to me.
Well, I thought I just told her to be objective, and now you're gonna.
I like to hear what she's doing.
Sorry, Carrie.
Go ahead, Carrie. What are you doing on the Phoenix?
My professor is one of the co-investigators for the surface stereo imager, so I basically do whatever she tells me to do for him.
CSI Phoenix. That's what it sounded like to me.
Hey, Carrie, by the way, why don't you let everybody know what you're majoring in?
Meteorology.
Meteorology, okay.
With an emphasis on?
The Martian atmosphere.
Cool.
Well, that's talk about getting ahead of the game.
That's
there.
right.
I mean, they're not doing daily weather reports.
Could you give us the 5-day forecast for the Martian surface over the next few days?
Very gassy.
A little bit dusty.
A little bit dusty?
A little.
Okay.
Two words for Carrie. Overachiever.
Not that there's anything wrong with that.
No, that's great. But that's only one item. One more news or another news item.
All right. While the Mars exploration rover Spirit was heading towards its winter haven, it uncovered an area of soil that is rich in silica. Scientists believe this patch could have been formed due to a hot spring environment or a fumarole environment where acidic steam rises through the cracks in the rocks. On Earth, both of these kinds of environments are full of microbial life. Steve Squires, the principal investigator for the rovers, says this concentration of silica is probably the most significant discovery by Spirit for revealing a habitable niche that existed on Mars in the past.
So, Carrie, tell me about these rovers. They're kind of getting ready to hunker down for the Martian winter. I understand there's this idea now with the Martian dust collecting on the solar panels that it takes longer to recharge those batteries.
Yeah, Spirit unfortunately wasn't cleared off after the dust storm that they had over the summer, so her power is really hurting. So they're trying to get her to the north-facing slope so she'll get more sunlight for the winter. Opportunity's in Victoria Crater, and the way that she's entering in is she's tilted toward the north, so she gets a lot more power, and her solar panels were cleaned off after the dust storm. So she's doing a lot better than Spirit.
Are there any He rovers on Mars?
Maybe.
Well, I don't know who's going to check because it'd be a little tough.
Carrie, by any way, do you have a pipeline into the NASA TV channel?
Yes, I do.
Okay.
Yeah, it's clear.
It's clear.
I don't know if we're even done with the news or not, but she gets an A+. I'm sorry. Anybody that can mention Mars and hot springs in the same report gets kudos from me.
Well, I gotta give kudos to Franklin because that's a great program getting our friends on the line to do the news.
And Carrie did an excellent job. I really think she did great. I think we should have her back soon.
Well, we'll see because I don't know whether how much tutelage Franklin gave you, but clearly, you have a gift here. We need to.
Hey, Carrie, you know what that means? If you do the news, and I guess Franklin gets to sit back and relax, and he doesn't need to work.
There you go.
Hey, thank you, Carrie. I'll mail you a check.
Perfect. Well, thanks so much, Carrie, for doing the news for us today. You did a great job, and hopefully we won't only just see you on Facebook, but perhaps have you come back and do some more news for us in the future.
I'll make sure not to be biased next time.
Oh, there you go.
Hey, Carrie, thanks so much, and we'll talk to you soon.
All right.
Hey, you're watching NASA Edge.
An inside and outside look at all things NASA.
She was great, wasn't she?
Great. She did better. We don't need Franklin.
Yeah. Goodness gracious.
Franklin, you're off the picture. Welcome back to NASA Edge.
An inside and outside look at all things NASA.
Hey, let's get to the significant portion of today's program.
Yes, the meaty part.
Yes, which are two cool projects from Dryden Flight Research Center.
SOFIA.
And IKHANA.
Perfect. And kudos to Franklin, who actually put us in contact with a lovely Sherry Olson from the Strategic Communication Office out there, who set a lot of this up and made it possible for us to see all that we saw
thanks
about
a lot,
those
Franklin.
missions.
That was a good contact.
I'm glad she took care of you guys.
She was the best.
And in fact, she even took us to where all the astronauts go.
Yes.
All the astronauts that land at Edwards Air Force Base.
Every last one.
Eat at a nice
Domingos.
restaurant. At Domingos, yeah.
I'm sorry. It's a Domingos, little Mexican restaurant. It's great.
It was
Perfect.
wonderful, yeah.
And it's interesting. When we went to the restaurant, there were all these pictures on the wall from each mission where the astronauts came in and actually ate there. So
yes,
really
that was pretty cool.
Yeah.
So
little slice of history there.
Are you guys going to be able to put your picture on the wall?
I left a lot of pictures of myself. I don't know if they're going to put it on the wall. That's
The first mission we're going to talk about today is SOFIA,
which is the Stratospheric Observatory for infrared astronomy.
Yeah, it's amazing when we talk about telescopes. We look at the ground-based telescopes.
Yep.
We have many of them across the country. Then we have the airborne, the space telescopes like Hubble. And soon to be James Webb.
James Webb, that's right.
But what about the airborne guys? And they kind of get left out in all this.
Well, they used to. get left out, but not anymore. They're putting SOFIA together, and it's going to be a perfect complement to those two. So it'll be interesting as we share with the audience what we learned. By the way, not a good idea to ask astronomers what their sign is, as I found out. They don't take kindly to that. Not that I believe in that, but incidentally, that was kind of...
Well, I tell you what, let's go ahead and see what took place at Dryden Flight Research Center.
All right, we'll do that.
Okay, cool.
All right.
Now the telescope, it's a pretty big telescope. It's about, 2.5 meters?
Right.
And it's going to be looking at the space in the infrared range?
That's right, yeah.
So what are some of the advantages of looking at space in the infrared range?
Infrared, it's just above the visual range where we can actually see with our eyes. With SOFIA, we're looking at stars that generated the light that we're looking at hundreds of millions of years ago. And so the infrared is actually able to see through that dust and see things that you can't see in the visual range.
So essentially what you're talking about is really high-tech baby pictures for stars.
That's right, yeah.
Now, what's sort of the long-term goals of SOFIA? How many years do you expect to use this type of aircraft and for the instrument to last?
The design is for a 20-year lifetime for the telescope and the airplane itself. We don't actually expect to start gathering astronomy data on stars until 2009. Yeah.
2009, okay.
Yeah, we won't get any pictures of stars, if you will, until 2009.
So really, when SOFIA is up and operational, I mean, this is sort of roughly around the same time where James Webb will be up. Mm-hmm. And of course, we have Hubble with this last surfacing mission coming up, and then we have all the ground-based systems. So it's really complements all the telescopes into one package.
Yeah, they really do, because Hubble does most of its work in the visual range.
Right.
And so the work that SOFIA can do actually will complement a lot of the other observatories.
Well, so what are the advantages then of having this infrared telescope on an airborne system as opposed to just launching a satellite with the infrared telescope?
If you're going to put an instrument in space on a spacecraft, you have to pick that technology between 5 and 10 years before the launch.
Okay.
Go ahead and develop the instrument.
Right.
And so when the instrument actually goes up in space, it's probably using technology that's at least 5 years old, maybe more. Wow. With SOFIA, because you land after every mission, and you can change the instrument out. You can actually be flying the latest and greatest state of the art.
It's easily upgradable.
That's right.
Easily upgradable.
I understand that the instrument itself was developed by the Germans, and there's a lot of international cooperation.
Yes, it's an international program, and the Germans actually built the telescope, and the U.S. supplied the money for the modifications to the airplane. And it's a quite large modification. There's a rather large hole that's been cut in the back of the airplane.
Now, the room that we're in now, this is a control room for SOFIA?
This is a mission control center for when we do flight tests on SOFIA. And right now, because we made such a large modification to the airplane, we're actually recertifying the airplane to be able to go do the mission that we want to do, and then be able to carry scientists and other people on board the airplane.
Hey, so maybe we can go get a chance to see SOFIA in the hangar.
That'd be great.
That'd be great. I think Jim Mills is waiting for you to show up down there right now.
Oh, cool. Perfect. Maybe we'll fly it.
I hope so.
Hey, we're here with Jim Mills, who's the avionics instrumentation lead for SOFIA. Hey, Jim, how you doing?
Good. Welcome to Dryden.
Hey, thank you very much.
I've got one quick question for you. Sure. Looking at this gorgeous airplane, I'm wondering, have you at least done away with that rigid class structure system where you've got people in coach and first class and all this animosity? Or
Actually, we don't have the first class, the economy class. We just have science class.
Science class. Okay. What about liberal arts?
Liberal arts. Well, they get to sit up in the piano bar.
Oh, there it is. I'm there.
Now, what we have behind us is a 747 SP.
That's correct.
And how's that different than a regular 747?
Well, the 747 SP standing for Special Performance. It was a plane that was built to climb to high altitude and cruise long distances at high speed. So to make it go faster, they took about 36 feet of fuselage out, made the plane lighter, put on special high-performance wings, which with the normal engines made it very fast, the fastest 747 made. And of course, NASA, liking things very fast, we put on bigger engines.
Okay.
And it was the perfect plane for flying an airborne astronomy telescope to high altitude. So that was a good choice.
So what kind of speeds are we talking about? Can this thing break the sound barrier, or is it?
Not intentionally, but it can fly at about 0.84 Mach.
Okay.
And that's pretty quick. Originally, it was able to fly at about 0.96 Mach, But with the telescope doors in it, they have decided to hold the speed limit down a little bit until the flight test is over, and then maybe they'll extend it.
Well, wait a minute. Is there some kind of like speed limit system up in the air?
Right. Their traffic controllers have radar guns, and they're keeping track of you all the time.
Oh, that's not good.
Right.
Yeah, you can't ever beat the system.
So really, the telescope dictated the type of aircraft that you were going to...
That's correct.
Okay.
Absolutely. It's a very large structure. It's about 40,000 pounds. Plus, we have a lot of installations for scientists to sit at, and teachers and people interested in the science that's going on in flight.
So Jim, where's the telescope going to be housed on the plane?
The telescope's located in what would be the aft cabin on a regular 747, about where the lavatories and the aft galley are located, behind a pressure wall, so that the telescope operates in the atmosphere that the plane's flying through. There's nothing between the telescope mirror and the outside of the airplane. The hatch tracks around to the opposite side of the airplane on a set of forward and aft tracks, and it's a 16-foot wide hole, and the door weighs about 1,600 pounds, and it allows the mirror to see right through the side of the plane.
Well, Jim, thank you so much for giving us a tour of SOFIA. That was a cool looking plane.
My pleasure.
You're watching NASA Edge.
Hey, an inside and outside look at all things NASA. Hey, welcome back to NASA Edge.
An inside and outside look at all things NASA.
Boy, that SOFIA aircraft, it's unbelievable, isn't it?
Yeah, it's fabulous. And I can't wait to see it when the doors actually open in flight and start gathering data.
And the fact that we might have the opportunity to be on that flight, it's going to be pretty cool.
Yeah, if we play our cards right. That would be great, Franklin. You'll get out there and actually sit inside SOFIA on one of these missions. It'd be great.
About 40,000 feet. It's going to be cool.
That sounds great. I'm surprised you didn't make it out there and get in the plane already.
Well, you know,
we tried everything we could, and if they were flying, we would have been there.
That's right.
You weren't able to work your mojo?
No. I tried.
Hey, but we got another cool aircraft we need to talk about.
The IKHANA.
That's right, which is a Predator drone that's unmanned.
Right.
Which means, there's no pilot in the cockpit.
Right, and which is frustrating because I thought maybe I could apply all my Xbox skills and maybe get a flight out there, Franklin, but apparently they do not honor experience points from Xbox Live.
Yeah, his pilot's license with Xbox doesn't work with this point.
So it's just not like a little joystick control deal?
No, it's very elaborate.
Well, they have a joystick.
It looks like a real flight cockpit.
Right.
I mean, it's got all the controls and all the everything you'd see in a regular
How many people
plane.
actually operate the drone?
It's one pilot.
One pilot?
One pilot. Well, we'll talk about that. We'll answer a bevy of questions after we check out the IKHANA.
That's cool.
piece.
Well, let's check out the second.
Yeah, let's take a look.
All right. Hey, we're here with Brent Cobley, the project manager for the IKHANA. And Brent, tell us about this great aircraft you have behind you.
Okay, what we got behind us is an unmanned aircraft. It's called the Predator B, and NASA's purchased this airplane so that we can use unmanned aircraft to do different types of science missions and also to develop technologies for unmanned aircraft.
And that unmanned, obviously meaning just like a remote control airplane, basically.
Yeah, there are some unmanned aircraft that are flight totally autonomously, but an aircraft like this actually has a pilot. It sits on the ground in a ground control station, so it's really a remotely piloted aircraft.
Oh, remotely piloted.
So what's some of the primary objectives of this aircraft?
So we wanted to use it to perform science missions. What we'll do is we'll take science sensors that need to study the atmosphere or the Earth, and we'll just carry them around. What's neat about this aircraft is it can fly for more than 24 hours.
Wow.
So you can actually collect data over a complete day-night cycle. So that's one of the key things we use the airplane for.
Now I understand that this particular aircraft took part in the wildfires?
Here at NASA Dryden, we work closely with NASA Ames and with the U.S. Forest Service. And so what we did is we integrated an infrared sensor. And what that infrared sensor does, it can see heat, essentially. And so by flying that over the fires, we can actually, essentially, like you said, take pictures of the fires, map out the fires, and then those images get sent through our satellite system that we're commanding the airplane with down to the fire incident commanders. And then they use that data to figure out where they need to put fire resources to be able to manage the wildfires. Early in the summer, we actually did some demonstration missions. We flew from here in Southern California as far away as Montana, Wyoming, and Idaho, and Washington State. So we were covering many, many fires in one long mission. So we did several of those kind of missions and basically developed the technologies and developed the way to use them. And then when the big wildfires popped up in Southern California, it turned into a real emergency. And the governor's office called and asked if we could respond to that, and we did.
Now, what are some type of other science experiments that you foresee in the future that might be used on this aircraft?
Yeah, there's a lot of different stuff in this sensor that's called a fiber optic wing shape sensing system. And using a very thin hair-sized fiber optic wire, we can measure the shape of the wing. And by doing that, we can design lighter and lighter wings for the future.
Nice.
And be able to fly instead of one day, maybe be able to fly airplanes that can fly for 3 days at a time on one tank of gas.
Now, structurally, what is this plane made out of? Is this an aluminum aircraft? Is it composites?
Yeah, it's made out of carbon composite, so it's very, very lightweight. In fact, it can carry, it almost doubles its weight when we load it with fuel.
Oh, really?
It carries about 4,000 pounds of fuel, and the airplane itself is only about 5,000 pounds.
Could it carry Blair?
Skip a few meals, grab a legal pad and some binoculars, strap this to the bottom. I'm good to go. I'm gathering data. Technically, this would be stowing away, but I think I can fit in the name of science. Why not? Yes, NASA headquarters. We have spotted the wildfires.
Whenever you fly high altitude or long duration, you really want long wings.
So a wing with a high aspect ratio.
Yeah, that's exactly right.
You know what that is? High aspect ratio?
Yeah, that's like 16:9 for your widescreen movies. I mean, that's
very,
right,
very similar.
Right?
We'll talk about that later. I'll educate you about that.
I like a widescreen.
So this section right here is sort of the heart and soul of the aircraft.
Yeah.
This is where all the
flight control computers, the navigation systems, the satellite systems all go in here. So that's the main part of the brains.
Okay.
The mid part of the fuselage is mostly carries fuel. So that 4,000 pounds of fuel kind of starts in here and runs all over the wing or into the wing. And then what you've got in the back here, you can see is because we've got the panels off right now, is this turboprop airplane.
This is great. You're watching NASA Edge.
An inside and outside look at all things NASA. So Franklin, what do you think? You think his pilot's license, the Xbox 360, could actually fly the Predator?
Well, you know, I logged quite a few hours on Xbox Live, so if he was up to where I am, he could handle it.
Oh, no, wait, I don't know. Because we were talking to the pilots out there, Franklin, and they said one of the differences is, I mean, there are lots of differences, but there's really no comparison other than the fact that you're not in a plane.
Right.
Maybe that similarity, but that's where it ends. I mean, they've got to run multi-hour-long missions.
And it's the real deal, because let's say something goes wrong. And I mean, they don't have a 360-degree window to look. I mean, they got to figure out what's going on right there in the in the trailer.
That's what they said.
No, but the other big thing, no, you don't get an extra life. You crash the IKHANA, and you're.
It's very difficult. I mean, it's a lot harder than they think. So,
you can't just reboot and start over again.
Right.
It becomes an other than honorable discharge.
Or something like that.
Speaking
it's a real
of
concern.
Speaking of IKHANA, what's IKHANA stand for?
IKHANA. What does IKHANA stand for?
Is it an acronym or is it just a name?
I know the answer to that. Do you?
Well, actually, it sounds like the place where I bought my new bedroom set.
No.
Okay,
no,
Mr. Insider.
It is not. It is not.
We interviewed the project manager, and
it's not. It's not. It doesn't stand for anything.
Are you sure?
I am positive. It is a Choctaw term, IKHANA. Right. So it doesn't you can't break it down and tell what it means.
Is that your final answer?
Yes.
Okay, spell IKHANA. What's IKHANA spell?
I-K.
Write it down. Write it down.
Oh, sorry.
I-K. H.
I don't need to wait for you.
A-N-A.
I know how to spell IKHANA.
I can't have another NASA acronym.
Wow, the host doesn't realize that can't is spelled with a C.
Sometimes it's also spelled with a K. from the IKHANA crew. Okay, now, before we wrap up the show...
I can't have another segment. We got to just...
Oh, no, we're going to have just a short segment. Okay. We actually, with our Facebook friends, we had a poll on Facebook. The question is, how did Blair get the job as co-host of NASA Edge? 1, he has a stellar resume in production. Mm-hmm. Not bad. 2, his mom campaigned for him. Mm-hmm. Third choice was he was endorsed by Chipotle and In-N-Out. Next one was the set therapist felt sorry for him.
Okay.
And then the final choice was he creates unusual road CDs.
Well, I've heard about 75 to 80% of those road CDs, and they're pretty interesting.
Right.
But if I'd have to put some money on it, Mom put in a couple calls for me.
Come on.
Okay, here are the results. 47%, which was the number one answer, says your mom campaigned for you.
Okay, 47% wrong, but that's okay.
How do you feel about that?
Well, I mean, I love my mom, don't get me wrong.
Right.
We have a great relationship, but she had nothing to do with me getting a job other than bringing me into the world and raising me as a creative genius.
We have a special Facebook friend online that actually helped out with this.
Is my mom on Facebook?
Well, I don't know. Is our Facebook friend online?
Hello?
Oh, is this Miss Allen, Mrs. Allen?
Hi, yes, this is Mrs. Allen.
Oh, how you doing?
How'd I get my... Hey! Oh, Mom, this is great. How did you do that?
It is Blair's mom on the line.
Well, Blair's smart, and he has a vivid imagination, and he's a creative thinker. So being the youngest of four, he developed strength early on to overcome adversity, and I thought he would add the spark, the red hair, to make NASA Edge an interesting and innovative show.
Wow. Look at that. You know,
Mom, are you freestyling that? Did you write that in advance? That's amazing.
She called several times to campaign for you for the job.
And Blair, you owe me one.
Oh, man.
I owe you quite a bit, Mom.
Well, thank you.
Wow, that's incredible. Well, thanks for coming on. This is great.
Absolutely.
Well, it was great. I enjoyed talking to you, and I'm really proud of you. You do a great job.
Well, thank you. Well, if you hold on the line, we'll talk to you. We're going to go ahead and let's sign off, and you're watching NASA Edge.
An inside and outside look at all things familial and NASA.
Have a great day.
Nice to hear from you, Mom. Oh, that's great. Man, you got me.